With best wishes, let me introduce myself. I am Nataraj Kuntoji, HOD, Department of Mechanical Engineering, Government Polytechnic, Bagalkot. This time, I have been allotted the Applied Thermal Engineering subject for 5th semester. So, in this session, we are going to study the Unit 1, that is Formation of Steam. And in this Unit 1, I'm going to cover the course outcome 1, that is determine steam properties and dryness fractions. It means how to determine or how to find out the properties of steam and also the dryness fractions. So how to determine these steam properties and dryness fractions, we will study in detail in further slides. So in this session, I am going to cover introduction part, formation of steam under constant pressure, conditions of steam, and multiple choice questions. It is a small test at the end. So based on the topics covered in the session. Let us start with the introduction, the phase transformation of water. You all aware and very well known how the water is going to transfer from one phase to another phase. So basically, the water is very important, the fluid, that to a mechanical fluid that exists in pure form. So this is called as a pure substance. What do you mean by pure substance? Pure substance means the water exists in the pure form. It means the composition of this water is not going to change even though it changes in its phase. So in the first figure, you are seeing here in the first figure, so it exists in the first, it exists in the solid state, then liquid state, then gas. So water exists in all the three phases, right? But there is a transformation takes place from one phase to another phase. So how the transformation takes place, so that is very important. We are going to understand that, right? So before this transformation from one phase to another phase, now I will explain something which we have learned in the previous semester, that is the basic thermal engineering. You know already, so the thermal engineering mainly it deals with the heat. So whenever you supply heat, then there is a changes takes place in the system. So I have explained what do you mean by system. System, whenever there is some process, there is a chemical process takes place. So that space we call it is a system, right? So in that system, whenever you supply heat, there is some chemical reactions takes place. The same way here also, if water exists in the solid state means the ice, solid state means ice, the solid form of water is ice, in it exists in the form of ice. So to convert this ice into a liquid, liquid means water, to convert solid into ice, what you need to supply the heat. You need to supply heat to the solid. Solid means ice. When you supply heat to the ice, it gets converted into water. Water means it is a liquid form or liquid phase. So I am showing here, this is a sign here, like this means it converts or it transforms from solid phase to liquid phase when you supply heat to the ice. So this process we call it as melting. So melting is a process wherein the water from the solid phase to it transfers from solid phase to liquid phase. It is a process. So how it takes transformation takes place from solid phase to liquid phase? By addition of heat. By addition of heat means you are supplying heat to the ice. When you supply heat to the ice, then it gets converted to a liquid. So I'll explain what is melting. Melting is a process wherein you are supplying some amount of heat or the addition of heat takes place to the system in such a way that it gets converted from the solid state to the liquid state. So when it is in a liquid state, again you can transform from the liquid phase to the solid phase. Means you can convert back from water to ice again. So what you want to do now at that point, whatever the amount of heat you supplied while transforming from solid phase to the liquid phase, the same amount of heat you need to extract it from the water. So there is a removal of heat here. So when you remove the heat from the water, then it gets converted back to its solid phase. So that the process we call it as freezing. Right? So here two terms you need to understand. One is melting and another is freezing. Melting takes place with the addition of heat and the freezing takes place with the removal of heat. When you add the heat, then definitely there is an increase in the temperature. I have shown here the sign here, increase in the temperature. I have written increase in the temperature. So there is increase in the temperature when you add the heat. So when you remove the heat, there is a decrease in the temperature. So the temperature decreases here. So now the water is in the liquid form. When the water is in the liquid form, then once again you keeps on supplying heat to the water. So when you keeps on supplying heat to the water, then again this water gets converted to a gaseous form. So gaseous form means the steam. It's going to form the steam. So what happens again here? Again you need to add the heat to the liquid phase. So again this process I am explaining here, this is called as evaporation. Evaporation, or I can call this also boiling. When the boiling of water takes place, then definitely there is a formation of steam takes place. So formation of steam means converting the phase from one phase to the another phase. One phase means it is in water phase, so then it gets converted to the gaseous phase. So here again there is addition of heat takes place. Again there is evaporation. Again there is increase in the temperature. So now it is in the gaseous form. Now it is in the steam. Once again you bring back to the liquid phase. So what you need to do here again? Again you need to extract the heat from the gaseous form. You need to extract the heat from the gaseous form. When you extract the heat from the gaseous form, then that is called as condensation. Condensation is a process wherein you are extracting the heat from the gas. So then that gas gets converted into a liquid form. So remember, whenever the water gets converted from solid to liquid, liquid to gas, but it is not going to change in its composition. So because of that, it is called as a pure substance. In its composition means whichever may be the phase, whether it is a solid or it may be a liquid or a gaseous, but it remains composition means that two molecules of hydrogen and one molecules of oxygen remains the same in any of the phase. Right? The same thing I've shown it in the second figure. In the second figure, I have drawn with respect to a heat, and with respect to a temperature here. So this is Q and temperature. So I have shown. So along the x-axis, so the addition of heat takes place here, and along the y-axis there is a temperature takes place. So here I have shown the point 1, 2 in the first one. So I have shown melting and freezing here, melting and freezing. From 1 to 2 it is melting, 1 to 2 it is melting, the addition of heat takes place. So when it is addition, so I have shown the direction on the right side direction, it shows the addition of heat. So that is called as a melting. So in the second phase, when it comes to 2 to 1, 2 to 1 means again in the reverse direction, then the removal of heat takes place, that is called as a freezing. So similarly, in the second one, I have shown this is the evaporation and condensation. Same way, the evaporation, again there is addition of heat, and in the condensation, again there is a removal of heat. So in this, from 1 to 2, it is a phase we call it as the evaporation phase. Then from here to here, it is called as the condensation. So I've shown it, both the drawings. So how the phase change takes place from one phase to another phase. Now, heat required for melting or freezing is called latent heat of fusion. Right? Heat required for melting or freezing. Here are two processes. It is a melting and freezing. whatever the amount of heat required for both the process, it may be a melting or a freezing, it is called as latent heat of fusion. Then both processes takes place at constant temperature called freezing temperature or freezing point. So because of that, I've shown with the straight line here. This straight line represents the temperature remains the same. The temperature is constant. So in such temperature, that is called as freezing point or freezing temperature. So its value is 0 degree Celsius at atmospheric pressure. Remember, the pressure is atmospheric. At atmospheric pressure, the value of freezing temperature is 0 degree Celsius. Next, evaporation and condensation processes takes place at a constant temperature called boiling temperature. So now again it is that is called as a freezing point. This is called as a freezing point or freezing temperature, but this is called as the boiling temperature, which is also called as saturation temperature. So remember this Ts, it is represented by Ts, that is saturation temperature. Remember, so this is a very important Ts in future point of time. Whenever you start solving the problem, the Ts is repeatedly used in the problems. So its value is 100 degrees Celsius at atmospheric pressure. We are taking here standard as atmospheric pressure only. So next we'll see conditions of steam. So there are three conditions of steam. The first one is wet steam, second one is dry steam, third one is superheated steam. These are the three conditions of the steam. So in the later stages, we will see what you mean by wet steam, what you mean by dry steam, and what you mean by superheated steam. How these three steams gets formed during the process, we'll see in detail with the help of some sketch. So now we'll see formation of steam at constant pressure. So this is very important. So this is asked repeatedly in the question paper. So formation of steam at constant pressure. So mark this as very important. So when you understand this process very clearly, then it's easy for you to solve the problems. So here the formation of steam at a constant pressure. We want to maintain the pressure constant. So if you want to convert water to a steam, so how to convert water to steam? By maintaining the pressure constant. Then how to maintain the pressure constant? That is our question now. So to maintain, how we are going to maintain the pressure constant? So I've shown it in the figure here. So this is a cylinder. So in the cylinder, the piston is there. On the top of the piston, some weight is added. So this weight is added to maintain the constant pressure. So this is you have to remember. Why the weight is added? To maintain the constant pressure. So there is a water is taken in the cylinder. So the initial volume of this water is Vf. I've shown it here, the Vf. This is the initial volume. So right. So then later to convert this into a steam. What is the process? To convert the water into a steam. So to convert water into a steam, what is required is you require a heat. You need to supply heat to this cylinder. So when you start supplying heat to this cylinder, as I told you in the basic thermal engineering, I only handled the basic engineering thermal subject in your previous semester. So I told you very clearly. So when there is a addition of heat takes place, then the water gets converted into a steam. So here, when you supply heat to the water, initially the supplied heat is absorbed by the water molecules. Water molecules, it will not move the piston upwards initially. Whatever the amount of heat you are supplying, it will absorb initially. So it absorbs initially means it's absorbed by the molecules of the water. It gains the energy. It gains energy, so it builds some amount of energy. With the help of that energy, it pushes the piston upward. So whatever the amount of energy it builds initially, so that we call it as internal energy. Right? So then you keeps on heating it, again it reaches the boiling temperature. So when it reaches the boiling temperature, so that boiling temperature I told in the previous slide, that boiling temperature we call it as the saturation temperature, and it is represented by Ts here. It is a Ts. This is the saturation temperature, right? So again you start supplying the heat again, then some amount of water starts converting into a steam. So here it is shown, still there is a water at the bottom, but here it is called as wet steam. What I mean by wet steam, I told in the previous slide, there are three conditions of steam. One is wet steam, dry steam, and super saturated steam. There comes the word wet steam now. What do you mean by wet steam? Wet steam means the water molecules are present in the steam. If water molecules are present in the steam, so that steam we call it as wet steam. So still it will not convert it. So the water is completely not converted into a steam. Still there is a some amount of water particles are present in the steam. So that is called as wet steam. Still you keeps on supplying the heat again. Now see, this is called as a dry saturated steam in the fourth figure. So dry saturated steam means completely the water gets converted into a steam. There is no water particles are present here. So this is called as dry saturated steam. Now this is the volume. This is called as a specific volume. Vg is the specific volume of dry saturated steam here. So Vg minus Vf, this is the total amount of increase in the volume. So whenever there is increase in the volume takes place, then definitely there is some amount of work is done. Remember, so when the piston starts moving upward, definitely there is some amount of work is done. But in this formation of steam, the amount of work done initially is negligible. We are going to neglect in the while solving the problems here. Then after the fifth figure, you keeps on supplying the heat. Then what happens again here? This dry saturated steam gets converted into a superheated steam. When it gets converted into a superheated steam, it behaves like a perfect gas. So when it behaves like a perfect gas, what happens now? So when it behaves like a perfect gas, then it obeys the gas laws. So what are the gas laws? So explained in the basic thermal engineering, there are so many, the gas laws are there, but at your syllabus we have studied 4 or 5 gas laws in your previous semesters. So we were studied in your previous semesters, right? That is Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, Joule's law. These are all the laws. So this superheated steam is going to obey, right? Then coming to this second figure, I've shown it here in the graph with respect to again with respect to heat and the temperature. This is, I have shown it in one direction, it is H, and so in the along x-axis it is H, along y-axis it is T. T means it is temperature. I've shown it here H now. So in the previous slide, I have shown this with respect to the heat and temperature, but now I am showing it is H. H means what? H is enthalpy. What do you mean by enthalpy? It is the amount of heat supplied to the system whenever the pressure is constant. If the pressure is constant, whatever the amount of heat you are supplying, so that heat we call it as enthalpy. So because of that, I am mentioning here, this is the H is the enthalpy. It means this is enthalpy versus temperature diagram, or I can say the temperature versus heat diagram. We call it as both the temperature versus heat or the enthalpy versus temperature diagram here. So whatever the process we did in these 5 figures, the same thing I have shown it in the graph here, in the drawing here. So I have written here the AB. AB is a line. It represents a sensible heat, or the total heat of water. So let us analyze now. So the point A is the starting point of water. At the point A, the water is taken in the first figure here. The water is taken in a cylinder, and on the top of there is a piston is there, and on the top of the piston there is a weight is placed. So when you start supplying heat to it, then what happens now? It keeps on increasing up to the point B. At point B, it reaches the boiling temperature. At point B, it reaches the boiling temperature. Then what is the amount of heat taken here? This is from A point to P point. A to P point here. This is represented by HF here. HF. HF means this is the amount of heat required to convert from initial temperature from 0 degrees Celsius to 100 degrees Celsius. So this is the amount of heat supplied, that is called as sensible heat or total heat of water. Then BC, I've shown here diagram in the BC again from BC. So that is wet steam, and at the C point it is called a dry steam. So remember here from B to C, the temperature remains constant. The whatever amount of heat you are supplying, but that heat is absorbed by the water molecules, maintaining the temperature constant, and it keeps on converting the water to a steam. So from B to C, from the B point, it keeps on going to the C point. You take any point in between B and C, the steam is wet steam. Up to here, from B point to here, again it is a wet steam. It means the water molecules are present in the steam, so that is called as a wet steam. When it reaches the point C, at point C it is called as a dry saturated steam. At point C it is dry saturated steam. Then there is no water molecules are present. At point C, the point C represents the dry saturated steam. Because of that, I have shown here BC is wet steam. At point C, it is a dry steam. But both BC up to C, I have shown here latent heat of evaporation. So from P point to Q point, from P to Q point. So this is HFG. It is called as HFG. HFG is nothing but it is latent heat of evaporation. HFG is amount of heat required to convert the water from its boiling point to the steam or dry saturated steam. So that amount of heat we call it as latent heat of evaporation. Then next it is C2D. C2D it is superheated steam. Superheated steam means once it reaches a dry saturated steam, you don't stop supplying the heat, you keep on supplying the heat. Then the dry saturated steam gets converted into a superheated steam up to a point D. So the whatever the amount of heat required to convert the steam from dry saturated steam to a superheated steam, so that heat we call as heat of superheat. H soup we call as H soup. This is this is heat of superheat, not H soup. Heat of superheat. The total amount of heat required from water to a superheated steam, that is from A point to R point, we call this as H soup, that is superheated steam. This is the total amount of heat required to convert water to a superheated steam. So this is H soup. So this is how you are going to explain the formation of steam at constant pressure, right? Remember, so whenever the pressure changes, then the temperature also changes. You know that. So whenever the pressure changes, the temperature also changes. It means the boiling point, it will not remains the same. The boiling point, now we are saying it is 100 degrees Celsius. The boiling point is 100 degrees Celsius. Assuming the water boiling takes place at atmospheric pressure. Atmospheric pressure means it is 1.013 bar. So at that pressure, if you start heating the water, then the boiling point is 100 degrees Celsius. If the pressure is more than that, if the pressure increases and the temperature also increases, the boiling point temperature increases. So it not only increases, it keeps on increasing. It keeps on increasing the pressure, or temperature keeps on increasing. Then still you keeps on increasing the pressure. Again the temperature increases. So like that, the boiling point varies. Not only boiling point, even dry saturated steam point, the C also varies whenever you increases the pressure. So let's see some multiple choice questions. So in this session, these multiple choice questions depends on the topics what I covered in this session. The first one, when water is heated with a rise of temperature, it consumes latent heat, enthalpy, sensible heat, none. When water is heated with rise of temperature, it consumes sensible heat. Sensible heat is the amount of heat supplied to a water when it gets converted from 0 degrees Celsius to the temperature, saturation temperature. That is the answer is C here. When water is heated without rise of temperature, it consumes latent heat, enthalpy, sensible heat, none. So when water is heated without rise of temperature, where there is no rise in the temperature, you have seen there is a point here. The point means from B to C. From B to C, there is no change in the temperature. So when there is no change in the temperature, still you are supplying the some amount of heat. So that is called as latent heat. So this is the latent heat. So the answer is A. Water at atmospheric pressure is a ideal gas, far below the critical temperature, far above the critical temperature, and none. So water at atmospheric pressure is a water at atmospheric pressure is a far below the critical temperature. Fourth one, internal energy is with respect to. Internal energy is with respect to A. Constant pressure, B. Constant volume, C. Constant temperature, D. None. Internal energy is with respect to what? The B answer is B, that is constant volume. As I said already, the internal energy means keeping the volume constant. Whatever the amount of heat you are supplying to the system, so that amount of heat it absorbs initially. It absorbs means the water molecules absorbs. It reaches its the saturation point, so it gains energy. The energy, it gains energy in such a way that so that energy is sufficient to push the piston upward. So the amount of energy what it absorbs before pushing the piston upward, so that energy we call it as internal energy. So internal energy builds up in the system, maintaining the volume constant. If volume changes, then we will say the work is done. So the answer is B here. Then fifth one, sensible heat of water is greater than the latent heat of steam, less than the latent heat of steam, equal to the latent heat of steam, none. So sensible heat is what? Sensible initial the amount of heat supplies is sensible heat. Later on it is latent heat of evaporation. Then the next one is it is the superheated the amount of superheat. So here the sensible heat comes at the initial stage, so it is less than the latent heat of steam. The answer is B. Next one, with the increase of pressure, the boiling point of water. So I explained whenever there is an increase in the pressure, the temperature also increases. The boiling point shifts now, right? It means that is also increases. So with increase of pressure, the boiling point of water decreases, no change, none. It increases. Weight increases, pressure increases, temperature increases. The boiling point shift. The seventh one, what is effect of increase of pressure on the enthalpy of steam? What is effect of increase of pressure on the enthalpy of steam? A increases, B decreases, C remains the same, D none. The answer is B, that is decreases. So thank you.